The world of 1939 aviation was defined by metal and massive industrial complexes. Every major power staked its military might on all-metal designs, believing aluminum and steel offered the only path to strength and speed. Britain's Royal Air Force needed a new bomber, but their specifications called for slow, heavily armed aircraft with a vast internal bomb bay. Sir Geoffrey de Havilland held a radically different conviction, an almost heretical idea born from his private design office. He proposed a bomber that was completely unarmed, one that relied entirely on raw speed for its defense and survival. This unorthodox concept flew directly against the prevailing tactical doctrine of the time, which prioritized defensive turrets and heavy armor. De Havilland's most controversial decision, however, was his choice of construction material for this revolutionary new machine. He chose wood, primarily balsa, and birch plywood, materials that were considered hopelessly archaic for a frontline combat aircraft. The idea was to laminate 2 layers of plywood around a balsa core, creating a lightweight yet incredibly rigid monocoque structure. This laminated sandwich was essentially a gigantic, high-speed wooden sculpture, an airframe that would leverage the strength-to-weight ratio of composite materials. Initially, the Air Ministry outright rejected the proposal, viewing a wooden bomber as a step backward into the Great War era. They scoffed at the lack of defensive armament, stating that no such aircraft could possibly survive in the modern European theater. De Havilland, convinced of his design's genius, decided to pursue the project on his own as a private venture, an immense gamble of his company's future. He saw that the country's vast pool of skilled cabinet makers and furniture manufacturers could easily be pressed into service, bypassing the already strained metal industry. This resourceful approach to manufacturing would prove to be a stroke of brilliance in the face of wartime material shortages. The inherent slipperiness of the wooden shell, meticulously smoothed and glued, would provide an unparalleled aerodynamic advantage. He correctly foresaw that this combination of lightweight and clean lines would translate into a speed advantage that no contemporary fighter could match. The project was tentatively designated the DH.98, but history would soon know it by the unassuming, almost delicate name of the Mosquito. It was a design forged by necessity and driven by the unwavering belief in a single principle: speed is the ultimate form of protection. The Mosquito's design was a minimalist masterstroke, sacrificing defensive systems for pure aerodynamic efficiency. Its 2 powerful Rolls-Royce Merlin engines, the same iconic power plants driving the Spitfire, were mounted on an airframe that was significantly lighter. The lightweight wooden structure meant that the engines could propel the aircraft to speeds that were simply unimaginable for a bomber. It was the ultimate expression of the light bomber concept, a machine built for quick delivery and immediate escape. The fuselage was constructed in 2 symmetrical halves, molded from plywood and balsa, which were then glued together like a giant model kit. This method allowed small furniture and piano factories to build major sections, drastically decentralizing production across the British Isles. The balsa wood, being incredibly light, formed the core of the structure, providing thickness and stiffness without the penalty of weight. Birch plywood skins were applied over the core, forming an incredibly strong shell that could withstand the stresses of high-speed flight. The absence of heavy armor plating and defensive machine gun turrets saved hundreds of pounds, translating directly into miles per hour. This focus on unburdened speed made the Mosquito faster than many frontline fighters of both the Royal Air Force and the Luftwaffe. Its top speed consistently exceeded 400 miles per hour, a figure usually reserved for dedicated interceptors. The narrow, sleek profile and high-mounted wing gave the aircraft a distinctive silhouette that was both elegant and purposeful. The designers effectively created a large, twin-engined fighter that happened to carry a substantial bomb load of up to 4,000 pounds. This meant the Mosquito could carry the same bomb tonnage as the four-engined American BR-17 Flying Fortress on shorter-range missions. The Mosquito's ceiling was also exceptionally high, allowing it to fly above the effective range of many German anti-aircraft batteries. This combination of altitude and speed made it a ghost in the sky, a target that was simply too fleeting to be consistently intercepted. The pilots quickly discovered that when a German fighter was sighted, the correct evasive maneuver was simply to push the throttles forward and accelerate away. This reliance on pure performance fundamentally redefined the tactical role of the bomber aircraft in the war. It proved that a well-designed, lightweight structure could be a more effective defense than tons of vulnerable steel. The German Air Command, the Luftwaffe, reacted to the initial reports of a wooden British bomber with a mixture of contempt and disbelief. They saw it as a desperate, backward move by the British, an indication of their perceived failing aluminum supply chain. Hermann Göring, the commander-in-chief of the Luftwaffe, famously declared that the British were resorting to using matchwood to build their planes. He publicly dismissed the unarmed bomber as an insignificant threat, deeming its wooden construction a sign of weakness. The prevailing German doctrine believed that any serious military aircraft must be built from metal to withstand combat damage and G-forces. The idea that a simple plywood aircraft could outrun the best of the Reich's fighters was considered preposterous by their engineering teams. This fundamental underestimation was a catastrophic intelligence failure, rooted in arrogance and an inability to recognize innovation outside of their own methods. German military thought prized heavy armor and cannon armament in every class of aircraft, rejecting that speed is life philosophy. When the first reports came back from fighter pilots claiming they had been outpaced by an unarmed, twin-engined aircraft, they were often dismissed as exaggerations. The lack of radar cross-section from the wooden airframe also made the Mosquito difficult for early German radar to consistently track, compounding the mystery. This initial Luftwaffe scorn meant that no serious priority was given to developing a dedicated, high-speed counter-interceptor. The Germans wasted critical months focusing on heavily armed but slower twin-engine destroyer aircraft. The very notion of a wooden bomber was an affront to their industrial might and metallurgical superiority complex. They assumed any wooden structure would be highly flammable and easily shot down by a burst of cannon fire. They failed to appreciate the superior quality of the balsa and plywood composite, which often absorbed light cannon rounds without catastrophic structural failure. A shell might pass clean through the wooden wing, leaving a neat hole, whereas the same round hitting an aluminum wing would cause far more extensive tearing and structural weakening. The psychological impact of this initial dismissal meant that when the Mosquito began its serious operations, the Luftwaffe was utterly unprepared. The German pilots had trained to engage heavy, slow, defensively armed bombers, not a fast, silent phantom that could appear and disappear in moments. The first prototype of the de Havilland DH.98 Mosquito, tail number W4050, took to the skies on November 25, 1940. The initial expectations of the Air Ministry officials who had reluctantly allowed the private venture to continue were extremely modest. What unfolded on that cold, late autumn day was a genuine revolution in aviation performance. Test pilots quickly realized that W4050 was not merely fast for a bomber, it was frighteningly fast for any aircraft. It demonstrated a top speed that comfortably exceeded 380 miles per hour, immediately making it faster than the current frontline Spitfire fighters. This incredible speed was a vindication of de Havilland's unwavering design philosophy, proving the effectiveness of the wooden composite structure. The engineers had created an airframe that offered minimal drag and a superior power-to-weight ratio compared to its all-metal contemporaries. The twin Merlin engines pulled the lightweight shell through the air with a stunning level of efficiency and grace. The aircraft's handling was reported to be exceptionally light and responsive, closer to a fighter than a heavy bomber. The performance figures shocked even the most skeptical Air Ministry officials, who were forced to immediately approve the design for mass production. The need for a high-speed reconnaissance aircraft and a pathfinder for night bombing had suddenly become acutely solvable. Its rapid climb rate and high operational ceiling added to its invulnerability, making it a formidable aircraft from the outset. The initial role of the Mosquito was immediately diversified, as the air staff realized they had acquired a multipurpose war machine. The success of the first flight put an end to the internal debates about wood versus metal, forever changing the perception of material use in military aviation. The test flights confirmed that the wooden airframe held up robustly under extreme G-loads and high-speed maneuvers. The material was stable, predictable, and, crucially, much easier to repair in the field than stressed skin aluminum. The shock waves from this performance quickly reached intelligence reports in Germany, though they were initially disregarded. The true significance of W-4050's speed was that it could fly over enemy territory in daylight, perform its mission, and return home without fear of interception. It was the birth of the Wooden Wonder, an aircraft that would challenge the supremacy of the Reich's air defense with nothing but pace and precision. The de Havilland Mosquito quickly evolved from a simple unarmed bomber into the definitive multi-role combat aircraft of the war. Its fundamental design excellence allowed it to adapt effortlessly to almost every mission profile the Royal Air Force could conceive. Initially, it served as a high-speed, unarmed photo reconnaissance aircraft, using its speed to dash over enemy territory and bring back vital intelligence. These PR missions provided commanders with up-to-the-minute details on troop movements, factory production, and target damage assessment. It soon transitioned into the role of a light bomber, utilizing its 4,000-pound payload capacity to execute pinpoint daylight attacks. The precision of these daylight raids was unmatched by the heavier, less agile four-engine bombers operating at the time. The Mosquito was particularly effective as a pathfinder, marking targets with flares to guide the main force of heavy bombers operating at night. Its speed allowed it to reach the target area, confirm the location, and drop its markers before enemy defenses could properly react. As the war progressed, powerful cannon and machine guns were installed, transforming the aircraft into a potent night fighter. Its speed and the eventual addition of sophisticated radar equipment made it devastatingly effective against German bombers over the UK and Europe. The twin Merlin engines provided a reliable and consistent source of power for these long night patrols over the continent. A fighter-bomber variant was developed, combining a heavy armament of 20mm cannons and 4.303 machine guns with the ability to carry external ordnance. These armed versions became legendary for their intruder missions, attacking German airfields and disrupting ground transportation networks. The versatility extended even to maritime operations, where some models were adapted to carry specialized anti-shipping rockets and bombs. There was even a modified version known as the Chtetzi, equipped with a massive 57mm anti-tank gun in its nose for ground attack. This sheer breadth of operational roles was unprecedented for a single airframe design during the conflict. The Mosquito became a one-stop shop for aerial warfare, capable of performing the duties of 3 or 4 separate aircraft types. Its success across these diverse missions highlighted the flexibility inherent in its wooden, streamlined, and lightweight structure. The Mosquito crews nicknamed their aircraft Mosses, recognizing the almost insect-like tenacity and elusiveness of the high-speed machine. One of the first missions to truly announce the Mosquito's existence and demonstrate its psychological impact was the 1942 raid on Oslo. The target was the Gestapo headquarters, a grand, imposing stone building located in the heart of German-occupied Norway's capital city. This was not a mission for a conventional bomber, as the precision required and the high-risk, daylight flight path ruled out heavy aircraft. The mission was specifically planned to be executed by 4 unarmed Mosquitoes from 105 Squadron, relying on their speed and low-altitude approach. The goal was twofold: to destroy vital German documents and records within the headquarters and to deliver a profound psychological blow to the occupying forces. Flying at virtually rooftop level, the pilots navigated the treacherous fjords and mountainous terrain to avoid early radar detection. The low-altitude approach minimized the time the aircraft were exposed to German anti-aircraft fire once they reached the urban area. On September 25, 1942, the formation roared over the city, the sound of the twin Merlins a terrifying shock to the German garrison. The pilots dropped their bombs with exceptional accuracy, striking the headquarters building directly and causing significant damage. The daylight nature of the raid, visible to the entire population of Oslo, was a profound demonstration of British aerial supremacy. It proved that the Royal Air Force could penetrate deep into German-held territory and strike targets with impunity. The immediate reaction from the Gestapo command was one of disbelief that such a daring, low-level attack could be carried out in broad daylight. The damage to the building was extensive, but the damage to German morale was arguably far greater and longer-lasting. This single, brazen attack forced the Luftwaffe to divert valuable fighter assets to Norway for defense, resources desperately needed elsewhere. It immediately invalidated Göring's earlier dismissive statements about the matchwood bomber and forced a painful reassessment of the threat. The Oslo raid cemented the Mosquito's reputation among both Allied and Axis forces as an aircraft capable of impossible feats. It was a mission that required not just a fast aircraft but also the immense skill and sheer bravery of the individual Mosquito crews. The success of the Oslo mission paved the way for more and more high-profile, precision daylight strikes against critical German infrastructure. Perhaps the most humiliating single action carried out by the Mosquito was the daring precision strike on the heart of the Reich itself, Berlin. The target was the main hall where Hermann Göring was scheduled to give a major public speech commemorating the 10th anniversary of the Nazi Party's rise to power. The raid was meticulously timed for January 30, 1943, the very minute Göring was due to begin his address to the assembled party elite. The goal was not primarily physical destruction but an explicit, public demonstration that the RAF could strike anywhere, anytime. 3 Mosquitoes from 105 Squadron were tasked with the daylight penetration into the heavily defended capital of the German Empire. Flying at extremely low altitude, they hugged the ground and navigated by map and stopwatch, avoiding the immense concentration of air defenses. The first aircraft arrived precisely on schedule and dropped its small payload of high-explosive bombs directly onto the official government buildings. The resulting explosions forced the immediate interruption and delay of Göring's crucial propaganda broadcast. Göring was unable to deliver his speech at the appointed time, a colossal embarrassment for the man who had promised a Germany safe from air attack. A second wave of mosquitoes followed, delivering a further disruption and ensuring the message was painfully clear. The news was broadcast on the BBC almost immediately, highlighting the brazenness and audacity of the daylight raid. The event sent shockwaves through the highest echelons of the Nazi government, sparking outrage and a furious investigation. Göring was publicly excoriated by Hitler for his failure to defend the capital against the very aircraft he had previously scorned. The mosquitoes had proven that their speed and low-altitude capability rendered the entire German air defense network ineffective. The raid was a stunning psychological victory, showing the German people that their leaders were vulnerable and their pronouncements were hollow. This single mission elevated the Mosquito from a successful military aircraft to a symbol of British technical and tactical superiority. It confirmed the Mosquito's legend as the aircraft that could literally crash the Führer's party and leave a trail of smoke and humiliation. The audacity of the Berlin attack remains one of the most famous and effective uses of air power in the history of the war. The initial Luftwaffe complacency regarding the wooden bomber was violently shattered by the series of high-profile, devastating daylight raids. They were finally forced to recognize the gravity of the Mosquito threat and develop dedicated countermeasures. German fighter production efforts were belatedly shifted to developing high-speed interceptors capable of catching the elusive aircraft. The Focke-Wulf Ta-152, a high-altitude, high-speed variant of the venerable FW-190, was one such direct answer to the Mosquito. This new design incorporated a longer wing and a more powerful engine, pushing its performance envelope specifically to catch the British flyer. However, the Ta-152 arrived too late and in too few numbers to have a meaningful impact on the ongoing war effort. Other standard fighters, like the Messerschmitt Bf-109 and Focke-Wulf FW-190, were adapted to fly lighter and faster to pursue the Mosquito. Pilots were taught new interception tactics, emphasizing high-altitude approaches and diving attacks to try and match the bomber's speed. The problem for the Germans was that the Mosquito was constantly being updated and improved, maintaining its crucial performance edge. As more powerful versions of the Merlin engine were developed, the Mosquito's speed continued to climb, staying ahead of the German interceptors. The Germans also attempted to create their own wooden aircraft, recognizing the material's advantages in weight and radar evasion. The Focke-Wulf Ta-400 and the Junkers Ju-388 were conceptualized, but the German wood industry lacked the British expertise and supply chain. German engineers struggled with the high-quality, specialized synthetic adhesives that were a vital component of the Mosquito's composite structure. The British Tego film bonding process was a secret weapon of sorts, a highly resilient adhesive that made the structure incredibly durable. Luftwaffe pilots found that even if they did manage to catch a Mosquito, its wooden structure often dispersed cannon fire in surprising ways. The lack of large, complex metal components meant there were fewer critical parts to destroy with a single burst of fire. The sheer frustration of trying to catch and destroy the wooden wonder took a significant toll on the morale of German fighter squadrons. The Mosquito evolved from a joke to a primary enemy target, yet it remained largely untouchable throughout the entire course of the war. The contribution of the Mosquito to the Allied bombing campaign reached its zenith in the crucial role of the Pathfinders. Before the introduction of the Mosquito, the accuracy of nighttime heavy bomber raids was notoriously poor and wildly inconsistent. Heavy bombers, flying at high altitude, often struggled to identify and bomb targets accurately in the blacked-out European landscape. The Mosquito, due to its speed, altitude, and agility, was the perfect candidate to lead the main bomber force to its target. Mosquito pathfinders were tasked with flying ahead of the mainstream of Avro Lancasters and Handley Page Halifaxes. Their primary mission was to mark the exact location of the target with highly visible, color-coded pyrotechnic flares, known as target indicators, TIs. These flares, often dropped with pinpoint accuracy, provided a blazing, unmissable reference point for the following bomber crews. The Pathfinder's ability to fly faster and higher meant they could evade the worst of the ground defenses and clear the area before the main attack began. The crews of the Pathfinder Mosquitoes were among the most skilled and dedicated airmen in the Royal Air Force. They were responsible for navigating vast distances in the dark, often in poor weather, using rudimentary early navigation aids. The increased bombing accuracy achieved by the Pathfinder force dramatically improved the efficiency and impact of the entire campaign. A significantly higher percentage of bombs finally fell onto the intended military and industrial targets, instead of open countryside. The Mosquito's presence in the Pathfinder role also served a critical psychological function for the heavy bomber crews. Seeing the brightly burning target indicators on the ground was a huge boost to morale, confirming that they were over the correct location. The Pathfinders effectively transformed the strategic bombing campaign from a blunt instrument into a weapon of far greater precision. The success of the pathfinding technique became a blueprint for all subsequent mass bombing raids for the remainder of the war. The silent, rapid Mosquito was the unsung hero that lit the way for the destruction of the Reich's war machine. The unarmed photo-reconnaissance variant of the Mosquito was arguably the single most important intelligence-gathering aircraft of the entire war. Designated the PR.Mki and its later variants, these aircraft flew longer, higher, and faster than any other Allied intelligence platform. Stripped of all armament and unnecessary equipment, their airframes were even lighter, further maximizing their already unparalleled speed. They were equipped with an array of highly specialized cameras mounted in the bomb bay, capable of taking detailed vertical and oblique photographs. These missions were often flown deep into the heart of the Reich, far beyond the range of regular fighter escort. A typical mission might see a Mosquito fly from Britain, cross over German-held territory, photograph Berlin, and return home in a single day. The pilots relied entirely on their skill, their sophisticated navigation, and the sheer speed of their wooden aircraft for survival. The intelligence gathered from these aerial photographs was absolutely critical to the planning of every major Allied operation. The images provided undeniable proof of the state of German factory production, the location of new V-weapon sites, and the movement of troop concentrations. For instance, Mosquito PR flights provided the photographic evidence that confirmed the existence and location of the secret German rocket research facility at Peenemünde. This discovery was vital, leading to the necessary bombing raids that delayed the deployment of the VR-2 rocket. The intelligence output was so timely and accurate that it gave Allied commanders an almost continuous, real-time picture of the war on the continent. The high-altitude flights also minimized the chances of the aircraft being detected by visual spotters or ground defenses. The camera equipment itself was highly advanced, featuring long focal lengths that allowed for detailed images from extreme heights. The information brought back by a single successful Mosquito reconnaissance flight could literally change the outcome of an entire battle. These brave, solo pilots flew their unarmed wooden planes through skies filled with flak and enemy fighters, entirely alone. Their work was a silent, unheralded campaign that underpinned the strategic decisions made by Allied command throughout the conflict. The Mosquito became the eyes of the RAF, constantly peering behind the veil of the Third Reich's defenses. The de Havilland Mosquito was not just a successful wartime aircraft, it represented a radical revolution in aerospace engineering materials. Its success forever validated the concept of composite materials in high-performance aircraft construction. The extensive use of wood, primarily balsa and birch plywood, was a precursor to the modern use of carbon fiber and other advanced composites. The core technology was the incredibly strong and durable bond created by the Tego film adhesive, a synthetic bonding agent. This specialized glue allowed the creation of a stress-bearing shell that was lighter and sometimes stronger than a comparable metal structure. The smooth, rivet-free surface of the wooden skin was aerodynamically superior to the panel-riveted construction of traditional metal aircraft. This reduced drag was a major factor in the Mosquito's legendary speed and efficiency at high altitudes. The method of decentralized, non-traditional manufacturing also holds a significant place in industrial history. Using furniture makers, piano factories, and cabinet shops demonstrated an innovative way to utilize a nation's existing skill base during total war. This approach diverted strain away from the specialized aluminum industry, which was already overtaxed by fighter and heavy bomber production. The wood construction also made the Mosquito far more robust in its resistance to weather and fatigue than was initially predicted. Its service life was long and reliable, a testament to the quality and durability of the laminated wood composite. The principles demonstrated by the Mosquito would later influence the design of early fiberglass and carbon fiber structures. Engineers saw that a rigid, non-metallic structure could achieve speeds and strength previously thought exclusive to stress metal skins. The concept of a lightweight, highly powered airframe that relied on speed for protection also left an indelible mark on tactical thought. The Mosquito proved that size and heavy armament were not the only metrics of a successful military aircraft design. Its legacy is not just in its combat record but in the fundamental shift it caused in how engineers viewed construction materials. It remains a potent example of how thinking outside the box, even using an ancient material, can lead to groundbreaking technological leaps. The de Havilland Mosquito ultimately flew through the entire war, remaining a vital, frontline aircraft from its debut until the final VE day. Its operational safety record was, for a high-performance combat aircraft, exceptionally good throughout its years of service. The wooden airframe proved to be highly resilient, and the twin-engine configuration offered a measure of redundancy that saved many crews. The Mosquito was never successfully countered by a dedicated German interceptor, a failure that haunted the Luftwaffe until its collapse. Its versatility meant that production lines were churning out specialized variants for every conceivable mission right up until 1945. It flew countless thousands of high-altitude reconnaissance sorties, providing the intelligence backbone for the invasion of Europe. It led the way for every major nighttime bombing raid as the indispensable light source of the Pathfinder force. It also served as a lethal night fighter, destroying hundreds of German bombers and intercepting VR-1 flying bombs over Britain. The total number of operational losses for the Mosquito, considering its high-risk missions, remained remarkably low. Its existence forced the German Air Command into a costly and ultimately unsuccessful diversion of resources to develop countermeasures. The aircraft stands as a permanent tribute to the ingenuity of Sir Geoffrey de Havilland and his team's unwavering conviction. They created a machine that defied conventional wisdom and taught the entire world a fundamental lesson in aerodynamic efficiency. The irony remains that the great industrial power of the Third Reich was outmaneuvered and repeatedly humiliated by an aircraft built primarily of wood and glue. The wooden wonder humbled the Reich, not with heavy armor, but with the elegance of speed and the power of radical simplicity. It is remembered today as one of the most successful and beautiful combat aircraft of the Second World War. The Mosquito remains a testament to the idea that sometimes the most unlikely solution is the most effective one.